Before we get started with chapter 9.2, I just kind of want to give an overview of where we're headed in chapter 9. So if we look at two cones, okay, a double cone, their intersection is each of their vertices. We can obtain different shapes two-dimensionally, okay? So obviously if we slice one of our cones um, on a flat line, we're going to create a circle, right? And you could do it in the top or you could do it in the bottom. Let's say we didn't do it at a flat line. We slice this cone kind of at a diagonal. That's creating an ellipse shape. And you can kind of see it here. The circle is when we slice it parallel with the ground, right? Flat. And then an ellipse is if we slice it kind of diagonal. But we can also create a parabola if we slice from the base of our cone down to the other side. The same thing here is the base of our cone, the bottom. If we slice from the base to one of our edges, we're going to be creating this parabola. Remember, a parabola is a U shape, and that's what it is looked like on a two-dimensional surface. Okay, but notice that the parabola only cuts through one cone. This line that you cut, you sliced through your cone, it didn't hit this bottom cone. Okay, so it's just creating one U, one parabola. But there is a time when we could create what's called a hyperbola. And a hyperbola is basically two parabolas. Okay, and that's when if you took your line and you sliced it from the base of one cone to the base of another. That's creating a parabola up top and a parabola down below. And you can see the same thing over here. Parabola down below and a parabola up top when you slice it from base to base. So those are the shapes that we're going to talk about: parabolas, circles, ellipses, and hyperbolas. So let's get started with parabolas in 9.2. We've seen a little bit of parabolas. We know that they're that U shape, right? They have arrows on the end. They go on forever. But I want to throw out a little bit more vocab there. Focus and directrix. Focus is a point somewhere on our graph in which lies on the axis of symmetry. And remember that the axis of symmetry goes through our vertex. Here's our vertex. And that's the point that starts the curve from one way to another. So our axis of symmetry, on it lies the vertex and what we call the focus. Okay, the other word, directrix. Directrix is a line. It's a line that's always going to be perpendicular with our axis of symmetry. So our axis of symmetry is in red, it's up and down. Then we need our directrix to be left and right horizontally. We need it to hit perpendicular. So our directrix is a line and our focus is a point. I want to point that out. Focus is a point, directrix is a line. So what do those mean? Well, if we look at our point in our line, any point on our parabola, right, maybe this point right here, that's going to be equidistant to our focus. So the same length from the black point to the red point, and it's the same distance from the black point directly down to our line of directrix. Okay, so if this happened to be, I don't know, 7.3 units, then this would be 7.3 units. And you can do that for any point on your parabola, right? It doesn't just have to be that one. It could be this one right here. If this was 2.9 units, and this length is 2.9 units. So it's equidistant. Any point on your parabola is equidistant to the focus as it is to the directrix. We're going to break this part down even more. but it's saying that we now have not a new form, but a form that's written in a different way for parabolas. So if your parabola is going to open up or down, we have this equation for all parabolas that do that. X squared equals 4 times p times y. X squared equals 4 times p times y. And we've learned before when we studied parabolas that it's going to open up if our p is a positive number, right? A number bigger than 0. But if our p happened to be a negative, a number less than 0, so like a negative out in front, that's going to flip it upside down, okay? So again, we have a focus point and we have a directrix. Um, and our directrix we're going to find is it's a horizontal line when we're opening up and down. Our directrix is a horizontal line. And that equation of our directrix, we're going to find that it's y equals opposite p. Okay, so where's p come from? P comes from inside this equation. Okay, so if we open up or down, we have the same equation and we have the same directrix line. It's horizontal. And we also have the same focus point. Okay, so it doesn't matter where that focus is, it can always be found at the point 0, comma, p. And again, p comes from inside of our equation. So essentially, opening up and opening down have all of the same parts, same directrix, same focus, same equation. And the only thing that may be different is our p might be a negative or p might be a positive. Remember that this little negative sign right here means opposite p. So if p started out being positive, we would change it negative. But if p started out being negative, this again means opposite. So we would change that sign. Okay, so you might want to put a little note that this symbol that looks like a negative sign really means opposite. Okay, and then the other part of this chart is what if we have a parabola that doesn't open up or down? What if our parabola opens to the right or to the left? Well, we still have all the same parts. We still have an equation, but notice the difference. The y's and the x's have switched spots. So if we're opening left or right, it's y squared equals 4 times p times x. Okay, so left or right, it starts with y squared. Up or down parabola starts with x squared. So up or down, x squared, and we have left or right is y squared. All of these, I forgot to mention, our vertex is going to be at 0, 0 for all of these, so we're never going to shift it. So that should make it a little bit easier on you. The vertex is at 0, 0. Let's look at the focus point and how it's different. So if we are opening left or right, our focus point is not 0, comma, p like it was for up or down. Our focus point is p, comma, 0. Okay, how is our directrix different? Well, instead of our directrix being a horizontally flat line, now our directrix is a vertical up and down line. So it's going to have a different equation. Instead of y equals opposite p, it's x equals opposite p. Okay, so all horizontal lines start with y equals, all vertical lines start with x equals. So again, this negative symbol really means opposite of whatever p originally was, so keep that in mind. I would really like these to be in your notes. Now again, Up and down have all the same parts. Okay, so you'd really maybe only need one of their graphs, and left and right have all the same parts. So you really only need one of their graphs in your notes. Okay, here is this chart simplified. So again, if we have an equation that in standard form is y equals 4 times p times x, that's going to be opening left or right, so a sideways parabola. Okay, it can either go this way, it can either go this way. But if we have an equation that says x equals 4 times p times y, so the y and the x's are switched, then we're either going to be going up or down. So it can be a parabola this way or this way. I didn't do very good use here. It's okay. Let's look at the opening left or right, the sideways parabolas. Every focus point will be of the form P, comma, 0. This is a great chart that summarizes the slide before. All of our vertexes for this unit will be at 0, 0, so we don't have to worry about that. They're not shifting. They're all going to be at the origin. The directrix. The directrix, remember, is a line, so it needs an equation, and it's x equals opposite p. Again, I'm going to write opposite because I do not want to forget that. It does not mean negative. So whatever P was in our focus, we change the sign. Opposite sign there on the original P. This directrix line, since it's x equals, it's going to be a vertical line. Oops. Okay, and I just like to reference that. It's a vertical line because it needs to run, it needs to run perpendicular with this line of symmetry. So if that's the line of symmetry, our directrix needs to be up and down in blue. The axis of symmetry, like I was just talking about, it's a horizontal line that splits our parabola in half. So that has the equation of y equals 0 since we're going through the origin. We're going through 0, 0. Okay, so the main ones are the focus and the directrix. You're going to have to know how to find those in a parabola. Let's go to up and down parabolas. So again, the equation x squared equals 4 times p times y. That's highly important. You have to know that it means up or down. The focus is at 0, comma, whatever p was in that equation. So we have to figure out p, and our focus is at 0, comma, p. Again, the vertex is at 0, 0. Making our axis of symmetry vertical through 0, x equals 0, it's a vertical line. But that means our directrix needs to be a horizontal line. Because it's perpendicular with our axis of symmetry. It's perpendicular with our vertical line. Horizontal lines have the equation y equals. And our directrix is always at opposite of P. Opposite of P. Okay, so this chart right here is your gold mine. Reference this as often as you need. Keep in mind the equation, the focus, and the directrix. Our first type of example is going to be graphing a parabola. So what we want to do first is, for step one, we want to make sure it's in standard form. So if this says y squared equals whatever, 20x, the original equation would be y squared equals 4 times p times x. Okay, so when I say standard form, I mean get y squared by itself, which it already is. Y squared is by itself. If I were given you the equation -1/8 y squared equals x, that's not in standard form because y squared isn't by itself. To get y squared by itself, you would have to multiply by -8, right? Canceling that out, and you'd have to do it to the other. Okay, so get it in standard form first. After you get it in standard form, what you're going to want to do is identify your P, your 4P. Okay, so if our equation is y squared equals 20x, that 20 stands for the 4P. Okay, so there's the x, there's the y squared. That must mean 20 is 4P. So if 20 is our 4P, what is our actual P? Because we can't identify the focus or the directrix here and here without knowing what P is. So that's our main goal, is to identify the P. So we're going to have to get P by itself by dividing by 4. 20 divided by 4 is 5. So that's a key piece of information right there. So after we identify our P, we're going to have to then come up with our graph, our focus, our directrix, and it also wants the axis of symmetry. So let's start with the focus. So if I go back to my chart, my standard form of this graph was y squared. So I know that it's going to be opening either left or right because it's in this row. So if I'm going to find the focus, it's at the point P, 0. If my P was 5, then my focus is 5, 0. My directrix. So again, I'm in the first row. My directrix is a vertical line at x equals opposite P. So the opposite of 5 would be -5. And again, the graph, I'm not going to make you graph certain points, but we do know that its vertex is at 0, 0. And we do know, since it's y squared, that it's either opening left or right. Okay, so it's sideways. Let's go ahead and plot this focus point at 5, 0, 1, 2, 3, 4, 5. And let's draw our directrix. It's a vertical line at -5 on the x-axis. And that's as straight as I can get. If this is our vertice, our axis of symmetry, again, back to our chart, is a horizontal line at y equals 0. So I can draw that axis of symmetry. I guess I'll do that in red. It crosses the y-axis at 0. It's a horizontal line. So there's our axis of symmetry. Our graph goes through the vertex 0, 0, and it's going to not cross our directrix, right? So in all of our examples, we have bowed away from this blue line. If the blue line's over here, we're curving away from it. If the blue line's up here, we're curving down. If the blue line's down here, we're curving up. So we don't want to cross our directrix. We want to curve around our focus point. So we're going to be opening to the right. So we'll plot our point at 0, 0. And you can curve it how you would like. I don't care about the other points. Technically, this might be wider than I drew it, but like I said, I'm not going to make you find those points. Just have a generic idea of this parabola. Where is it opening? Where is the focus? Where is the directrix? And where is that axis of symmetry? So again, I can label these for you. This is the focus. This is the directrix. The red line is the axis of symmetry. This black dot, you already know, that's our vertex. And that's all there is to it. The second type of example that you might see is writing the equation of a parabola. And I like these because they go a lot faster. So if this parabola has a focus at 0, 3 and its vertex is at 0, 0, we're supposed to come up with the equation of this parabola. So I like to work backwards. If the focus is 0, 3, that means we have a focus of 0, comma p. 0, comma p of a focus means our equation starts with x squared. So if it's 0, comma p, we know we're going to be using x squared equals 4 times p times y as our equation. Well, good news is we already know what p is. P is 3. So we just go ahead and we substitute in 4 times 3 times y, and we just simplify to get our final answer of x squared equals 12y. That's the equation of a parabola that would have a focus at 0, 3 and a vertex at 0, 0. Let's say instead of given the focus first, that we were given the directrix. So this parabola has a vertex at 0, 0, and our directrix is x equals 4. So let's take a look at that chart. Underneath directrix, when we have x equals, we know we're using the equation y equals 4 times p times x. Y squared equals 4 times p times x. And I want to go back and look at that chart underneath directrix. X equals opposite p, right? Opposite the original p that's supposed to be in the equation. So in our directrix, we need to look at the opposite of positive 4. So if in our directrix it says x equals 4, we know that our p is actually negative 4 to begin with. Okay, so then we plug in our negative 4 and we multiply to get y squared equals negative 16x. That's the equation of our parabola that has a directrix at x equals 4, that's the line, and a vertex at 0, 0. Please, if you have questions, visit office hours.